this one, what we want to do is, well, the question number 2 is asking for the slope of the best fit line. And the slope of the best fit line is line B, so I'm just going to draw real quickly over that. It's that black dashed line. And I already drew some nice points on here for you. And what we want to do is now use the rise and the run grid on here already to find our slope. So we're just going to count. You got to be careful not to count boxes. If you're watching this and you got this wrong, it's probably because you counted boxes rather than what each box is worth as far as numerical value. Now, over on the y-axis over here, we go from 35 and 36, 37, 38, 39, 40. We're counting by ones. Okay? And on the x-axis, we're going from 1, but the next box isn't 2. The next box is in between 1 and 2. So we're counting on the x-axis by 0.5s, 1.5, 2.5. So we're going to use this to show that this line here, if we're talking about a run first, I'm going to do it in blue. It starts at 2 and goes to one line past 10. So since we count by 0.5s, that's going to be 10.5 where it goes to. Okay, so from get to 2 to 10, that's going to be 8. And then if we add another 0.5, our run is going to be 0.5. And I'm going to always add my units with this. So it's not just 8.5, it's 8.5 centimeters. Okay, and the rise now, we can actually just count boxes here because we said each one's worth 1. So if we start here, because that's where my rise was taken, I'm going to start at 34, go to 35, 36, 37, 38, 39, 40, 41, 42, 43. So it went to 43 and it started at 34. So to get from 34 to 43, if I draw that, from 34 to 43 is going to be 9. And it's not just 9, but you got to look at the units. It's 9 newtons. So in order to get my slope, I need to take my rise over the run. So my rise from my graph was 9, and my run from my graph was 8.5. And I'm going to, again, add my units with this. There we go. And so the first question is asking, number 2, it's asking me to just, well, do my rise over run. So if you have a calculator, you can go ahead and do 9 divided by 8.5. And when I do 9 divided by 8.5 on my calculator, I get 1.0588. And the problem says to round to the hundredths place. So I need to round, this is the tenths place, this is the hundredths place, so I'm going to round it up because the 8 is bigger than 5. So my number that I should write in here is 1.06. Yeah, I should write 1.06 in there after we round to the hundredths place. All right, now my units. The units, since I kept my units with my number, they're already on here. Since I kept my newtons with my 9 and my centimeters with my 8 by looking at the axes, okay, all I needed to do was just look at what that creates. And it should be newtons per centimeter. So that would be, I believe, the third one on here. I can't quite see. But it should be newtons divided by, and I think on the question it looked like this, newtons divided by centimeters. Newtons per centimeter, that's your unit. And if you can imagine, this is something that we would use for like springs. How many newtons of force would it give you if I pulled it a certain amount of centimeters? And so that's a very valuable number there. And that's how we got question 2 and 3.